In question 2 here, we're looking at monohybrid inheritance. We're just looking at one trait. It says in humans, tongue rolling is a dominant trait, whilst those with a recessive condition cannot roll their tongues. So one of the first things I'm going to do is actually state what letters I'm using. So I'm going to say, let big T equal tongue roller, little t equal a non-roller. So I've stated my alleles. Now Bob can roll his tongue, but his mother could not. He's married to Sally, who cannot roll her tongue. What's the probability their firstborn child will not be able to roll his tongue? So we want to do a genetic diagram. So the parent phenotypes, you have Bob, who can roll his tongue, and he is married to Sally, who is a non-roller. In terms of F1 genotype, Bob can roll his tongue, so he must have at least one big R gene. But then he could either be homozygous dominant or heterozygous. There's another piece of information there. It says up here, his mother could not roll her tongue. Therefore, she was little r, homozygous recessive, and he must have inherited one of those little r's, one of the recessive alleles, from his mother, so he is heterozygous. Sally, on the other hand, is a non-roller, and as non-roller is recessive, she must be little r. We then do a cross. You can either draw a Punnett square, or you can just look at the different possible gametes, and that's going to give us the F1 genotype. I just realised I did that wrong. That should say up here. That should say parent genotype. F1 genotype. They could either inherit the big R from Bob and the little r from Sally, or they could get the little r from Bob and the little r from Sally, which means that the F1 phenotype is therefore going to be 50% roller, 50% non-roller. So looking back at the question, what is the probability the firstborn child will not be able to roll his tongue? The answer is 50%.